Hey everyone, welcome to my stream. So a couple nights ago we worked on cleaning up the gamepad code, and after that I just polished up a couple more things related to that. I was able to test the 2-player gamepad thing, and I put in a little rule that said that if I have no gamepads, then the keyboard will be used for player 1. And it's still hard-coded through the keys that I put in there. Then after that, and then after that, if you connect a gamepad and there's one gamepad, then that becomes player 1 and keyboard becomes player 2. And if you connect 2 gamepads, then, well, those become player 1 and 2 and the keyboard won't be used. So I put all that code in there. It's right here. So I check if player 1 has a gamepad, if player 2 has a gamepad, and I just say, like, if not player 1 and player 2 have a gamepad, then we want to use the keyboard. So if one of them is not there, we want to use the keyboard. So we figure out which one. Just wondering why. Yeah, I call this joystick index, but it's more like player index. But anyway. And then after that, we go and we do the gamepad stuff. So that works. Alright, sorry about that. Some network issues. So today, what am I going to work on? So ideally, I was thinking that I'd want to work on starting to improve the graphics stuff. Now, I am not really a graphics programmer, and you know, what I've done so far is extremely basic, you know, like OpenGL immediate mode crap here. Like, where is the code? Oh yeah. Has to do with the display, right? Okay, here it is. So basically we have this like display with clear and draw line, and that's the extent of the drawing code really. You know, there's some OpenGL setup stuff, viewport stuff. That's all set up. But the kind of thing that I want to look into replacing is in here. Well, specifically in here, where I'm right now just drawing immediate mode GL lines and points for I'm actually drawing points for when the line is so small. And I think I did that because short lines don't really show up when I draw the GL lines. That was what was happening for, like, for example, for the stars in Mindstorm. Sorry, a little bit distracted there. Okay, so what I want to do is I want to use just a basic shaders. I want to write like probably what's it called, shader model 3 shaders, because I think that's, you know, fairly compatible and gets me what I want. It's modern enough and fairly compatible. I have like a little bit of experience with shaders, so like, you know, just close a couple things here. Let's see here, OpenGL shader model. So yeah, I'm gonna want to write a little bit of HLSL, the high-level shader language. Oh no, actually not this one. I want to write the one from OpenGL. Where are the OpenGL shader models? I know there's a nice little Wikipedia on OpenGL. Was it in here? GLSL, that's it. This is the one. So yeah, sometime in 2010 they released this one here, 3.30, to go with OpenGL 3.3. And I think that's when they basically introduced some nice features in the shader model that just kind of make it easier to write shaders. So what I want to do is I'm probably going to have a very basic, like the default vertex shader that's just going to do what it normally does. And then it's really in the fragment or pixel shader that I want to do something a bit more interesting. And that bit more interesting is basically when I shade the lines that have been drawn, yeah, something like, basically I want to know, like, for all the pixels that we need to shade, I want to kind of like bring down their brightness over time. And I guess the challenge there really is the fact that to make it work in the way I'm thinking, I'd have to keep redrawing those lines every frame, but that's not really what I want to do. So what I was thinking is something like, maybe I can share a little bit my thoughts with the picture. So like, what I was thinking was that we'd have, let's say, this texture, and I would do like a render to texture through the shader. So like I'm sure I can do, I haven't done it before, but I'm sure I can do this. Like somehow say I'm going to be sending a bunch of like vectors that I want to draw, and it will actually draw it into this texture, right? So like we imagine, you know, I draw this and then kind of like this, something like that, right? And then I would like, if we think of, so that's a texture, right? And then I want to have like another pass, I suppose these are passes, where this texture is drawn as a full screen quad. So the whole thing just gets drawn full screen. And when I do that, I think that I will have a chance to shade every pixel of the texture, because it's a full quad, right? So I'll have a chance to shade every single pixel. And what I'm hoping to do is then for every pixel, just take the value and then start bringing it, the colors, you know, and bring them uniformly down to 0. Because it'll be, you know, some form of, well, in this case I'm drawing black on white, but it'll be more like, you know, actually what will I do? Yeah, so I'm going to be drawing white lines, and then I'll want to be bringing the white down to black through grays. And in fact, the white lines too, I will draw them with brightness and taken into account. So the initial line will be drawn with the correct, you know, grayscale value to represent the brightness that the beam is currently set at, and then I would get, that's it, uniformly bring those values down. And so I never actually need to clear this thing, right? It'll just always be something I draw to, and then, like I said, this whole thing gets drawn to the screen, and then it's in the pixel shader that I bring down the values. So that's sort of what I'm thinking. Now, how to do that, I'm not even 100% sure. It's been a long time since I've written shaders. Like, by a long time, I mean it's been like, say, a year since I wrote very basic shader stuff, and I haven't done much other than that, you know. So I'm probably going to be reading a lot of sample code and just adapting it and slowly putting something together. So I guess I'll start by just like reading a little bit about OpenGL render to texture. See what comes out there. What we're going to render to is called a frame buffer. It is a container for textures and an optional depth buffer. see here. So gen frame buffer, bind frame buffer. So there we go. Now we create the texture which will contain the RGB output of our shader. This code is very classic. Okay, so this is the handle for the texture. We generate the texture. Then we bind it. So this becomes the selected texture. And after that, we like create the actual buffer for it by giving it the size and the values it'll store and all that. Poor filtering needed. Okay, so this is using nearest neighbor. Poor filtering needed. That's interesting. Okay. We also need a depth buffer. This is optional depending on what you actually need to draw on your texture, but since we're going to render Susan, we need depth testing. So I don't actually need depth testing in mine. We're always drawing at z equals 0 plane. It's a 2D screen of vectors, right? Finally, we configure our frame buffer. So set rendered texture as our color attachment number 0. Okay. GL frame buffer texture. Set the list of draw buffers. So GL frame buffer texture. I just want to look this up. Attach a level of a texture object as a logical buffer of a frame buffer object. These commands attach a selected mipmap level or image of a texture object as one of the logical buffers of the specified frame buffer objects. Textures cannot be attached to the default draw and read frame buffer, so they are not valid targets of these commands. For all commands except GL named frame buffer texture, the frame buffer object that is bound to target must be read frame buffer is equivalent to GL draw frame buffer. Okay. So this says OpenGL 4, so I do wonder if this even exists in OpenGL 3. Okay, there's also GL frame buffer texture 2D, which only attaches a single face of a specific MIP level. So what we're gonna do is we're gonna like write some kind of sample code, and once we get something close to what we want, then I'll be bringing that in. Hey Michael C. Michael C says, how's it going? Going pretty well, you? Just reading about render to texture in OpenGL. So set the list of draw buffers. One is the size, okay. So we configure our frame buffer. So this basically sets up frame buffer texture. So I'm guessing what you're supposed to do is when you do this, this becomes the active like target of the frame buffer, and so then subsequent draws will go and draw into that texture, and then after that you probably have to unset the frame buffer texture or somehow reset the frame buffer to be the screen. Let's keep reading this. So rendering to texture. Rendering to the texture is straightforward. Simply bind your frame buffer. Oh, okay. And draw your scene as usual. Easy. So render to our frame. So we bind this frame buffer. We select it. Ah, so you have a frame buffer name. Did I miss that part? Is there a name up here somewhere? Oh, frame buffer name. Oh, okay, sorry. The frame buffer name is just the handle, the unique integer. Okay, so we bind it. Render on the whole frame buffer, complete from lower left to the corner to the upper right. The fragment shader just needs a minor adaptation. So this means that when writing in the variable color, we will actually write in the render target 0, which happens to be our texture, because draw buffers of 0 is color attachment I, which is, in our case, rendered texture. Okay, let me read that again. Okay, it's this specification of location equals 0 in the fragment shader. So this is basically saying that when we write to the Vec3 color for each pixel we're shading, we're actually writing to location 0, and this was bound above, as he's saying here. What was it again? I guess it's this. Yeah, it's this here. So this means that when writing the variable color, we will actually write in the render target 0, which happens to be our texture because draw buffers of 0 is GL color attachment 0. Yeah, so that's what this means. Set render texture as our color attachment number 0. Okay. So to recap, color will be written to the first buffer because of layout location 0. The first buffer is GL color attachment 0 because of draw buffers of 1 equals GL color attachment 0. Yes. GL color attachment 0 has rendered texture attached. So this is where your color is written. In other words, you can replace GL color attachment 0 by GL attachment 2 and it will still work. No, there's no layout equals to I in OpenGL less than 3.3, but you can use GL frag data vi equals mpvi. So yeah, that's what I remember, is that starting from 3.3, shader model 3.3, we get nice features in the shader language, like being able to specify a location for outputs like this. Using the render texture. We're going to draw a simple quad that fills the screen. We need the usual buffers, shaders, IDs. So the full screen quads frame buffer object. Okay, so he basically generates a vertex array and binds it, selects it. Then he says we're going to generate a vertex buffer object here. So we gen a buffer, we bind, and we give it the data, which is this array for static drawing. Create and compile our GLSL program from the shaders. So this is going to load a vertex shader and a fragment shader. So pass through vertex shader. So the pass-through vertex shader, if I recall, is just basically a simple shader that passes through the vertex values so that the default transformations will occur based on the current matrix and yeah. And then there's a simple texture fragment shader, which does what we'll have something like this in it among other things. So we'll take a look at that. Create and compile a GLSL program from the shaders. So yeah, and then get the uniform location of rendered texture from the okay, so rendered texture. So that's going to be one of the, I think it's the input variable. We don't see it here though, but it'll be one of the input variables from probably the fragment shader. And get uniform location of time. So now you want to render to the screen. This is done by using 0 as the second parameter of GL bind frame buffer. Okay, so that's what I was saying earlier about you bind, you know, here he binds to the specific frame buffer that is bounded to the texture by calling GL bind frame buffer somewhere up here, and you give it the index. But if you set it back to 0, then that means we're going to be drawing back to the screen now. Render on the whole frame buffer, complete from the lower left corner to the upper right. Sure, we can draw our full screen quad with such a shader. So what it says here, in Vec2 UV out Vec3 color, uniform sampler for the rendered texture. Okay, so that's what this is. It's getting the I'm just thinking about how this is probably a different shader though, right? Is it? There's the time. So this corresponds. These uniforms correspond to the two guys over here. And basically, what are we doing here? We're saying set the current color to, and then we sample the texture at. And he's doing UV plus. All right. Right, so basically when we draw the full screen quad, we need to set the UVs for the quad, and so over here we're going to be using the UV at, you know, the current sampled UV for the current pixel, and then here he's just doing some kind of transformation to give it a cool effect, which you can, you know, we're not seeing it live. It over time it'll change the way it looks. It'll probably be doing some kind of movement stuff. Sine of time plus and then uv.x and then cos of time uv.y. So basically, I think what we're going to see is that the pixels would cycle over a certain pixel distance over x and y over time. So it gives it some kind of cool effect. Okay. I found a pretty handy tutorial here. Can I just download it from here? Tutorial source code on GitHub. Tutorial 14. Render to texture. Here's a pass-through vertex shader. Just want to check the license. And there is no license. But this is OpenGL tutorial, so I'm gonna assume that we're allowed to use this stuff. I don't see anything about licensing, but I think it should be okay. So let's grab. Looks like I should be grabbing all of this because there's a CMake lists file over here. So let's just clone this. Data code. I'll just clone it into here. And I can't type. OGL. Maybe I'll call this OpenGL tutorials. Like I said, this stream will be mostly me reading and experimenting a bit with OpenGL to start laying out the foundation for how we're going to do it for the Vectrex emulator. Okay, so I've cloned this code. So yeah, it's got a CMake file, so let's create a build folder. I like to put build 2017, let's say, so I know what I expect. CMake ... and let's see what happens. So see, it detects that I have Visual Studio 2017, and hopefully it'll generate my solution. Looking here on my Twitch dashboard, and it looks like there was a drop in my bandwidth for like about a minute or something, about 2 minutes ago. I don't know if you guys noticed anything. Okay, so CMake looks like it generated what I needed. That looks cool. Tutorials.sln. Okay, so here are the tutorials. There are examples, there are tests, then there are some other things here. And then we got those tutorials here. So let's go grab the render to texture here, set that as my startup, and see if this even builds. Builds cleanly, that's nice. See if it runs. Okay, so it does run, and we just move this to the screen here, and there we go. So yeah, there we go. You can see like that effect that I was talking about in terms of the this weird thing where it tracks the mouse movement. So now I lost it. Oh. Move. There we go. Yeah, so we can see that there's this cool effect when rendering the pixels because it's doing the sine and cosine in X and Y direction for each pixel using this constantly moving time variable that's being passed to the shader. It's got some weird mouse stuff going there, like I can't even resize. Whoa. It's this mouse tracking code. Anyway, it doesn't matter. Okay, so it is using glue, which is nice. I was thinking of using that. So glue is this OpenGL like framework extension wrangler library. And it's meant to basically like wrap the part of OpenGL used to set it up and like set up the environment for different platforms and stuff like that. I don't actually need that part of it because I'm using SDL, which already sets up OpenGL for me that way. But I think there's maybe some other parts of glue that might be useful, that not just for the setup. So we'll see. Right. Load shaders. Okay, so there's some helper functions and stuff like that that we're going to want to get something similar to. Oh, this is nice. Just looking for licenses in here. Can't find anything. Okay, so that's how the load shader works. VBO indexer. Yeah, so this is the kind of stuff that you get from glue. Or is it GLF? No, this is GLFW. Oh yeah, GLFW. Am I getting this wrong? GLFW. Okay, that's different. It's an open source multi-platform library. Provides simple API for creating windows, contexts, and services, receiving inputs and events. So that's one thing. And then glue is another. Oh, this is for extensions. That's right. This is for giving like a common API for checking if there are certain extensions that exist that would work across the different versions of OpenGL and the different cards and all that. Again, not something I have to worry too much about. Yeah, there is the part where we need to tell OpenGL which version, major and minor version, we want to use. So if I'm not using this, I'm gonna have to look at how to do that in SDL. wonder if I pick this out. This is all the stuff that has to do with hiding the mouse and stuff. I wonder how it works if I undo this code. Not working much better. Okay, anyway.
This should be played at high volume, preferably in a residential area.
Accept fragment if it is closer to the camera than the former one. Okay. Call triangles which normal is not toward the camera.
Ladies and gentlemen, we are experiencing technical difficulties. Please stand by.
Okay, so create and compile our GLSL program from the shaders. Standard shading RTT, standard shading RTT. So yeah, this standard shading, this is probably like the, we'd have to take a look at these, but these for sure are the ones that just do like the kind of typical texture and lighting style shaders. So like they basically mimic the fixed function pipeline, most likely. Let me take a look. So here's the vertex shader and fragment shader. Actually, could I open them in here? Tutorial 14. Okay, so they're in here. Shaders, here they are. Right, so we pass positions in model space, UVs, and vertex normals in model space. Will be interpolated for each fragment, so we output the UV, position in world space, normal in camera space, eye direction, camera space, light direction, camera space. Values, let's take constant for the whole mesh. And then this is the standard fragment shader. Honestly, I don't need most of this. So that's the model view matrix here. Material diffuse color, so it's sampling this texture here. So basically this standard shader supports one texture for diffuse. For the ambient color, it just basically multiplies, it uses the diffuse value, but 10% of it for the ambient color. And then for specular, it's fixed at 0.3. So like, this is very hard-coded type of shader. So we'll probably end up modifying this because we don't really want this kind of look. We just kind of want very simple. We just want to sample the texture and then draw it as is with no lighting affecting it. So I don't really need any of this, like the light position, any of that. The eye position, I don't need this either. no reflection, none of this. In the end, for me, it's just going to be setting the color to the value from the text, sampled from the texture. So it's going to be very simple. It's going to be a lot closer to what this wobbly texture fragment shader does. Okay. Now, get a handle for our MVP uniform. Load the texture. I think I have a viewer for DDS files. Anyway, get a handle for my texture sampler uniform. Loads this guy. Index VBOs. This creates the index vertex buffer. Load it into a VBO. All right, now the specific code. Frame buffer name 0. So this is the code we saw in the tutorial page. So this is where he creates a special frame buffer for the render to texture, and in the texture we're going to be rendering. We generate that here, bind. The depth buffer. Right. Color attachment 0. So I suppose that's what's used for if you want to have multiple textures. Right. But I suppose, yeah, you'd have different frame buffers for each one, and then for each frame buffer you'd say which attachment to use. I wonder if you could reuse the same attachment for multiple frame buffers. I suppose so. Oh no, I suppose the idea there would be if you have, for a given frame buffer, you could have multiple textures that you render to, each one with a different attachment, and then in your pixel shader you could write out to any of them based on the bound out that you give it. Depth texture alternative, the list of draw buffers. Oh, right, okay. Trying to understand why there was 6 entries. It's because it's 2 triangles for the full screen quad. So we send that in. I find it strange how at this point it does load shaders rather than do it earlier. Normally I'd want to compile these early on. So he calls this the quad program ID. So there's the load shaders up here for like the main program, like the main render, and then here is a specific one for drawing to the texture. And you get the texture ID and the time ID. I think I'm right about that. Render to our frame buffer. So this selects that render to texture frame buffer. Clear it, use. Okay, no, actually that's right. So this here is for rendering to the screen, and the other standard shaders are actually to render to the texture. And I guess that makes sense. The idea there is we want to render to the texture using a normal, quote unquote normal texture and lighting and vertex transformation pass. And then after that, we want to just take that and just render it to the screen, and in this case with a very simple fragment shader that does the little wobbly effect. And this pass-through vertex shader, which just takes the vertex position in model space and just sets it as the output position to pass to the vertex shader, the fragment shader, and then does will be interpolated for each fragment. Yeah. Yes, okay. Yeah, that will be interpolated and passed, and then this here we have to interpolate the UV itself. Okay, whatever. Clear the screen, so use program ID, so that's the main shaders, compute the MVP matrix from the keyboard and mouse input. So this is the code I'd have to get rid of for that, getting rid of that behavior. Send our transformation to the currently bound shader in the MVP uniform. Right, so in our case here, we would just send identity matrices. We're not really doing any transformations for the Vectrex emulator. What does get your matrix do? Okay, yeah, just to look at. Man, I must say I'm feeling really tired today. Don't know how much longer I'm gonna last. It's been a busy week for me at work, so just kind of beat, to be honest. Final texture and texture unit 0. Okay, so here basically what was happening is we're setting up the inputs to the shader. So we're saying, you know, we're binding GL texture 0, and then we're saying like active, we want to make the slot TL texture 0 slot active, and then to that we bind our texture, and this is texture here is the image in this sample, right? In our case, it's going to be something we draw to. So we'll actually try it in here. We'll try drawing instead, and we'll see, like, we'll draw a few lines and we'll see what that looks like, rather than yeah, rather than draw a texture, we'll want to just draw some lines. Yeah, so we won't really need this texture sampler stuff. Just need a really simple shader. Alright. So the first attribute buffer are the vertices. This is standard stuff. We just want to send it the vertex buffer. And so this we will have built from the lines that we want to draw. We won't really need UVs. We won't really need normals. Yeah, this is the index buffer because he's using an index vertex buffer object. Draw the triangles. So this basically draws the indices, and these are the indices that come from the vertex buffer object that was created from the vertices of the Suzanne object. Ah, okay, right, and then the texture is basically just the texture that gets mapped to this 3D model. That makes more sense. So this is drawing the 3D model of that Suzanne object that we saw. Now we disable these because we're done with them. Yeah. First is vertices, second is UVs, third is normals. Okay. So once we've done this, once we've drawn here, it's used the shader that was the two shaders that were selected earlier, the standard shaders. After that, we render to screen. So now we unbind the other frame buffer and rebind back the 0 frame buffer, which is the screen. And now we render on the whole frame buffer, complete from lower. So then it proceeds to clear and says, I want to use that, you know, the pass-through vertex shader with the wobbly texture fragment shader. And then it says, okay, yeah, rendered texture. I just want to look at this again. Okay, that's it. So this is the part where we take the rendered texture is bound to the output here. Yeah, so this is the, if we look here, if we follow rendered texture, so when it created this texture here, we got the uniform location ID of rendered texture from where is it? Oh no, okay, no, I'm getting confused. So rendered texture refers to the uniform in the final fragment shader for the screen. Right. Okay, so basically we're just setting up the, we're just basically saying we want to use this, we want to set up this uniform here so that we can now pass it in the quad and the texture that it gets. Now that's the part I'm just trying to see here, is we rendered to a texture, so where is the part where we pass in that texture? Quad vertex buffer. Okay, I think the glue is here. Set our rendered texture sampler to use texture unit 0. This text ID here no, that's just this rendered texture here. What am I missing? Apart from sleep. And using the generated texture. Let's see. Using. Okay, so I guess it has to do with this here. To use texture unit 0. Texture unit 0 was previously bound to the texture that was drawn to above here. Yeah. See here, GL active text. So that's what's tricky about this, is you really have to understand the contracts in OpenGL's API. So basically, earlier on, when we are first rendering to texture and into that frame buffer bound to that texture, there's this active texture, GL texture 0, and then we say we want to use, in this case, this texture here. Set our myTexture sampler to use texture unit 0. So if we go back to the standard fragment shader here, color here is bound to location 0, right? Which means that when we write to this, it's going to write to that 0th texture unit. So it's going to write to this texture, I think. So this sampler here is being used to sample the texture, to put that nice texture, the colored texture that we see on the model. Sure, okay. I guess the part I'm not getting here is that is this thing about the location 0. What is it actually drawing to then? In render target 0, which happens to be our texture, because draw buffers of 0 is content, which is in our case is rendered texture. Where is rendered texture? Oh, it's here. Bind the newly created texture. All future will be modified in the texture. Give an empty image to OpenGL. The last 0 means empty. Okay. Set rendered texture as our color attachment number 0. Oh, okay, so it's not this. When we are going to render to texture, the glue is here. This is the one that says set this texture that we created to be the output of the frame buffer, the one that the frame buffer was bound to. And then we render to that, and that's set in color attachment 0. And then when we're done, that texture now has all the data we drew into it. And then that same named rendered texture is what we bind to the uniform in the wobbly texture fragment shader. And now that becomes an input here. But it's not because of this name, it's because it's in slot 0. Like texture unit 0 here. Yeah, okay, that makes sense. Okay. So let's see if we can mess around with this program a little bit. Don't even know if I need the position in world space, but we'll see. So let's say I remove... Okay, let's remove even this one. I think all I need is the GL position. Technically don't need these. I'm probably gonna break everything. Okay, so in here, don't really need to sample and input texture either. I just want to draw a line to this guy. Don't want any of this. Oh no, I do want this actually. Well, I just want to sample this guy here. Let's just do this. From the like that. Yeah, you can see like I don't need any of these inputs really. Is that true? For the fragment shader, I just need to... Oh no. Getting confused again. This is not my texture sampler. Sorry, this is not what I was thinking. What I need here is... Right, so I'm trying to think, how do I know what color I'm supposed to be setting here? If I don't have material. Basically I need to pass in the color, that's what it is. That's what's missing here is I will actually want to pass in color values. Okay, so for now I'll just keep it white. Because basically the shader is written with just, you know, sampling, like the idea is we will always apply a texture and we don't care about vertex colors, but I want to pass in, you know, vertex color. This is gonna be so broken. Just curious. Oh, well, it's not totally broken. Here we go. White. That's a good start. So let's say we have that and we want to try and draw, rather than draw that model, we just want to draw some lines. Can I get rid of this here? Get the view matrix. Okay, so this is the stuff that makes it compute matrices from inputs. Is there like a compute matrices without inputs? I guess that's just the way it's coded. Okay, whatever. The only thing I really need is the model view matrix, which gets built from these matrices here. Send our transformations to the currently bound shader. So we need these. Care about the light, bind our texture in texture, so I don't even care about this. Okay, so here, this vertex buffer here, this is the vertex buffer that was built from this like object, the Susan object. What we want to do instead is we want to make one that's dynamic, that we draw to every frame. So I'm going to kind of like hijack this code a bit here. Do they have like a function to create? Let's see here. Load obj. Okay, so basically given a set of vertices, UVs, and normals, this guy will create a vertex buffer object and spit out these values here. So another way for me to do this is not to create an index buffer, but it's just to create a regular non-indexed vertex buffer. Oh, this actually tries to figure out. Right, that's cool. Okay, it doesn't even create the VBO. This just says, you'll give me a vertex, a bunch of vertices and UVs and normals, and I'll produce for you, you know, a decently good index buffer into it. Yeah, okay, that's kind of cool actually. And then after that, it creates what it needs. So technically I don't care about this aspect of it. I just need the vertices and the indices. like I can get rid of these two and it should still work if it builds. Just trying to dumb this and simplify it down to what I really need. Yeah, so it still works. For some reason it's traveling. Why is it moving? Oh, it's moving because I moved it to the other screen. It has to do with the fact that it's because the screen that I'm showing here on OBS is my secondary monitor, and so when I launch the program, it actually launches on the primary monitor. So there it's fine, but when I move this window to the secondary monitor, like the mouse values that are being read are a little bit strange. So there's some weird stuff where it starts like moving the camera because it thinks the mouse is like on the side or something. Okay, there we go. See, like now it's flipped. Anyway, whatever. Okay, so that's good. But now what I want to do is I want to build my vertices on the fly rather than from that object. Where was it? Yeah, here. Okay, so I'm gonna need to mess around a bit more now because I have to move this code down. So, well, actually, let's start with something static. So rather than do this load obj here, let's try to fill in our vertices. Let's see. What does this guy look like? Vec3. XYZ RGB. Guessing it has an implicit constructor for 3 values. I'm just going to assume it does. Let's see. So let's say at 0, 0, 0 to this guy was using, let's go 500, 500, 0. And I'm going to need UVs for each of these, even though I don't really need them. Actually, can I do basically, I'm just adding as many elements as there are vertices into UVs and normals, and I'm just like default constructing them because I don't care about their values. But I think it needs to match when we call the function here to the index VBO function. It's probably going to want them to match. and we can see it here. The fact that it indexes into all three using the same I means we need them to have the same number, and that makes sense. Okay, let's just see if this actually does something. JazzX94 says, wow. Okay, so I see nothing. So that's not a super good sign. Let's see. I'm thinking it's because my Z value is 0, and probably it's getting clipped by the default camera setup and the near plane and all that, so that's usually the issue. Did they do something to position that object a certain distance from the camera? Actually, I didn't see anything about that. Maybe I'm wrong. Like, it's possible that it gets created at 0 and then the control code makes sure to back up the camera. Just gonna remove depth testing and culling just to make sure that that's not what's getting in the way here. Okay, it doesn't seem like it. Actually, one thing that I can do that would help is let's load this again just to take a look at what the values look like in there. Just get a feel for the range of values for vertices and all that. Okay, so we see that there are 2,904 vertices. Ah, interesting. Okay, so it's like in a 0 to 1 range. So then that tells me that the frustum must be set up like basically the units are not so large. And they did seem centered around 0. See again? Yeah. Yeah, this is totally centered around the origin. So, I mean, what I'm doing by adding 2 vertices. Oh, and that's another thing. Okay, it wants triangles, so I can't have just 2 vertices. I need at least 3, of course. That makes sense. So 0, 0, 0, say 0, so 1, 0, 0, 2. Actually, let's put some 0.5, 0.2, 0.1, 0.10, to 0.9, 0, 0, to 0.9, 0.90, something like that. Ah, there we go. Okay, we just move this here. So we got a triangle, yay! Okay, so this guy is trying to draw triangles.
it, but now I'm back. And I'm sick of all these bitches talking shit behind my back. So if you got a problem with me, then come and spill it. Cause nigga, when my red bus is cage, I'm gonna kill it. I forgot my roots when y'all start licking my boots. I turn on to the kitty, oh, like I was the motherfucking roots. But you better believe that this nigga's so from the street. Flowing road out the garden, but motherfucker smoking weed.
How do I draw?
Says to keep out the vault.
Right, to GL draw arrays and GL draw elements.
Keep out the vault.
Sorry, just give me a second. Alright, sorry about that. Okay, so let's keep hacking away at this code. So there's the GL draw. So we're telling it to draw triangles, right? So if instead of this, we say to draw lines, then basically every pair of vertices should represent a line. So we go back to, well, let's just start with that and see what we get. So rather than a filled triangle, I'm hoping to see a funky looking line. Okay, let's take off that effect that we have right now. Yeah, so it makes sense we see one line. We have basically one line and the start of another line. We're gonna go through the wobbly texture. We're gonna stop making this wobbly. Just sample the thing at UV. Oh. What did I do wrong? Oh, right. Like this. Okay, so there's our beautiful looking line. Very nice. So now we can make the line, let's make two lines that are disjoint. Alright, so here we are again. Point 3.8 to say 0.3 to point, say 8 in X, and 0.8 to 0.1 in Y. Okay. So that's cool, right? So now what I want to try and do is to do the kind of fade out effect on this, because ultimately that's what I was hoping to do for the Vectrex. So let's see if we can do that. Now to do that, I need to not clear and redraw this every frame. I need to kind of draw this once every, so often, and leave the frame, the frame, like not clear the frame buffer. So let's start with that. So here we don't want to clear. Now it's possible I need to do at least one clear for, is there a binding up here? There is. So what I'm going to do is just make sure to do at least one clear, because some video cards really don't want you to bind the buffer and not clear it at least once. Actually, what I'll do is I'll do this here. Alright, so we've cleared it once, we don't clear it anymore. Now, I need some kind of elapsed time. I saw that there was a timing function that was being used here. Returns the time of the GLFW. Gotta love how it shows this, but that when I hit F12 to go to it, it goes to this version. Input.c. There it is. Here. Okay, so returns the value of the timer. This function returns the value of the GLFW timer. Unless timer has been set using the timer measures time elapsed since it was initialized. The resolution timer is system dependent, but is usually on the order of a few micro or nanoseconds. It uses the high resolution monotone. Okay. Okay, so this is an elapsed time. All right. Do they offer like a frame time, or it doesn't have that concept? Okay, so we'll do our own. Okay. Like that. Get the time. And the last one is current, the next frame. Okay. Great. Now we'll have a elapsed time to redraw. Let's say every 2 seconds or something. I think it's in seconds, right? Did it say that? In seconds, okay. So if it's time to redraw, then we do all this drawing stuff. Once every second. Okay, so it's not actually drawing, so there's something wrong. I saw a warning when I built. No, sorry, I don't want to build all this. Just cancel. Build this guy. Oh, okay, because I put float here. Okay, so what is it that it doesn't like? Oh yeah. Need to reset my timer. That would help. But that is not working either. Make sure this still works. It's possible that there's some code in there that I need to run every frame despite whether I draw or not. Okay, so that worked. Actually, what's funny is because I'm not clearing anymore, so if I do this, and then I move my mouse, there. It's really hard to control, but there we go. See, I can, by moving my mouse, I'm turning the camera, so it's drawing in the relative position on the frame buffer. It's kind of neat, actually. So maybe I don't need a timer, because if I can move the mouse and just gradually make it go dark, yeah. Yeah, so forget this part. Oops. Alright, now for the gradually bringing it down, I need to pass in an elapsed time. So right now we're passing at a global clock, but that's not what we want to pass into the fragment shader. Just want to pass. What do we want to pass? Yeah, a delta time, exactly. So we'll just treat this time here as delta time. What do I call it? Frame time? Oh. I meant to call this frame time or something. Frame time. That's a better name. Okay, so this becomes frame time. So that's what this guy is. And we want to subtract let's say we want to make it take 1 second to get to 0. The simplest thing. So then we what do we do? We want to interpolate this value towards 0, just based on the delta time. Yeah, that's how you do that. Okay. So let's say instead we do Vec3. And what is it? How do we interpolate again? Mix? Yeah, it's mix. Did not like that. Cannot convert from three-component vector of vectory to float. Oh, right. I need all three values in there. No? Undeclared identifier of final color. Okay, well, it doesn't look like it's going to black. But the problem here is that I'm not writing back out to my texture. This is not working because I need to actually do this and write back out to the texture. Can I do that? Can I write, can I, like, can an input texture be an output texture in a fragment shader? Like this rendered texture, could it also be an out? Interesting. So there are different techniques. And then so this person says after you've gone and rendered your full screen quad with the shader, that's what we're doing, right? Then you can copy back the resulting frame buffer to the original texture. That's interesting. feels really hacky though, right? Copying the frame buffer of the screen back into the texture. But I guess it's either that or I have to modify that texture. There's this here, apparently. I wonder if I could use this extension. Looks like it's pretty old. But this one looks like a simpler solution. I guess I could try this. Doesn't hurt. So he's binding to the back to the one that what he calls the bio handle, original texture handle. Oh, okay. So we still have the screen as the current frame buffer, but then we say take the original, the old texture, make it the current one, and then we say copy text subimage, which will copy from the current frame buffer to the currently selected texture. Okay, let's give that a whirl. Don't know if I should be doing it before swap buffers. I don't know if I have to select it again because it's already selected here, but anyway, just to be sure. We want to bind our texture. I think these were hard coded, right? 1024 by 768, was it? Oh, it's doing something. But not what I expect. When I started, just went brighter over time. I want to see if I move this down here if it makes a difference. It is interesting how it gets brighter up to a point. Actually, okay, so actually he is selecting the other frame buffer. I'm not sure I understand that part, but it doesn't seem to be doing anything. Does that make sense? Okay, so this replaces a rectangular portion of a two-dimensional texture image, cube map texture image, from the current GL read buffer. Hey BD, how's it going? I realize actually this doesn't make all that much sense of it. Oh no, this makes sense. Yeah, it's a full screen quad. Not bad. How about me? Honestly, I'm really tired. So like, taking me a bit longer to trudge through this, but I'm getting somewhere. Starting to look at looking at using shaders to do the rendering of the vectors. I'm using this tutorial that's really quite good, and I've been hacking at the code and at the shaders, And now what I'm trying to do is I'm trying to do the kind of fade out effect that I want for the vectors on screen. So yeah, it's pretty interesting. So I got to the point where, you know, I can render arbitrary vectors like this, and I'm not clearing the screen, so then when I move the mouse, that turns the camera, and so you can see it's kind of like effectively drawing it everywhere based on the camera position, which is fine. And what I want to see is I want to see these lines kind of fade to black. But to do that, the trick is that I have to render to this texture the lines, then render that to the screen, and then kind of read back the screen in which, when I'm rendering to the screen, I'm actually bringing those colors, those fragments, like the pixels, I'm drawing them and interpolating them towards black, ostensibly. I'm using time here, and I'm saying for each pixel on the screen, bring it towards black. Which honestly, I'm starting to wonder if that's really where I should be doing it. I mean, it should work anyway. Just to be sure, if I was to pass here 0.9, sorry, Vec3, let's say 0.9, will this draw darker lines? Okay, it does. You see? So this is bringing the whole screen to black. So technically this would be working. Now time, yeah, so the idea is that time is in seconds, and so this would bring it to 0 in 1 second, let's say. If it was full bright, like a pixel that's fully white would go to 0 in 1 second. Because I'm passing here time as delta time, but that only makes sense if I am indeed kind of doing making the output become the input again. I need to create that feedback with the texture, which is what I'm trying to do here, copying the screen frame buffer back into the texture, but I seem not to be succeeding. Let's see what other people say. Yeah, this is what I was thinking, is I could maybe do it with 2 different textures. There is an extension, that's what he's talking about here. Shader image load store, yeah, that's what the other person mentioned. However, I wouldn't recommend it, especially for learners, since the extension is tightly limited and might not be supported on every hardware. That being said, is it possible? You can use the same texture as a frame buffer texture attachment and render to it as a texture sampler to look up values in the shader, but not in the same pass. That means if you have 2 textures, you could read from A and write to B, and afterwards switch textures and read from B and write to A. So basically like kind of double buffer in a way. That would work. So like basically if I so let's say this is texture 1, and then this is texture 2, and this is the screen. I guess I can do it like this. And then like we'd want to, let's say, draw a line here, and this is, let's say, the first texture, and then this here ends up getting copied to the screen, right? Okay, no, actually, so this is the first thing, we select this and we draw to it. Then that's like the first pass. In the next pass, we want to draw this into texture B. That's it. Yeah, so then let's say, so the first time we draw it into texture B, and then what happens is that, and then texture B starts to do the darkening thing, bringing it down to 0, right? And then that, of course, gets copied to the screen. We draw that to the screen. And then we swap the two, right? So that the next time around, do I need to swap the two? No, actually I don't need to swap the two. This is very confusing. Draw here, go there. Oh right, okay. The key here is that this texture in the shader has this as input and this as output. That's right. Okay, that's the part. So in terms of my shader, this guy is like input. This guy is output, right? And then the shader says read. The fragment shader says read all the pixels and then draw them, you know, and darken them into this one. And then we draw that. And then if we swap that, the next time around, yeah, and then this guy becomes input. And then this guy becomes output the next round. And what that means is that for the next pass in the fragment shader, this guy becomes input, has the darkened values in them. So that works, right? And of course we draw into the input. So if we have new lines to draw, we will draw them there. So that makes sense. So that's really, this would work, and it would work on any, pretty much any OpenGL. So I would need a second frame buffer, and I need to kind of do this swapping thing. So that's a good plan. But I'm looking at the time and I'm thinking it's getting kind of late. So I will do that next stream. And what we'll do is we'll like start cleaning up this code and removing all the deleted code so that I can factor out the, now that I'm going to have these two frame buffers and I'm going to be swapping between them, I won't be able to make it as hacky as I have it here, I think. Can I? Maybe I can. Let me just think for a sec. Okay, I can remove this stuff. Yeah, that's fine. Okay, so let's say, what would I need to do here? Noticing that this code probably should have been using window width and window height to really center the mouse. Anyway, whatever. Okay, so I'm going to rename this frame buffer name to frame buffer texture 0 or text 0, text ID 0. And we're going to gen another one. Text we're going to render to. Wait, the texture we're going to, okay, so actually, do I need another? I don't think I need another frame buffer. I just need to create another texture and then just swap the binding. That's what I need to do. Make sure this still works. Still works, so we do this. We'll gen another one. So we'll bind 0 here and give an empty image to it. So we'll do that here. And we'll do the same thing here where we bind 1. Oh, and I need to also do the filtering. Depth buffer. Don't really need this actually. It's still working. Alright, so now I ostensibly have created 2 render textures. So now we set render texture 0 as our color attachment number 0. So this is not something we're going to do once. Here was being done once. We're going to want to do this, and we're going to want to alternate. So we're going to say this, and then we're going to say whatever, just to make it alternate between 0 and 1 for every frame. So here we're binding the texture that we want into color attachment 0. Okay. So this is where I'm going to need a different shader to do the darkening. Called darken texture, a fragment shader. So actually it's this one, and then wobbly texture, which won't actually be a wobbly texture, will just do the normal sampling of like this. Now we need to compile that and select it and do the extra pass. We're going to use the pass-through for the vertex, and we're going to use the darken texture for the fragment shader, and then this one will be called the render to texture, and this will be darken texture program ID. But this one actually is going to be closer to the other one. This will be pass 1. This here is pass 3. Okay, and pass 2 will be to darken the texture. So we use this guy. Now here's the key, is how we do these bindings here. Yeah, so this second pass is a lot like the third pass. So I'm gonna start by copying this. Now, can I set this after binding that frame buffer? Okay, well, let's say I do it before. So we do the same thing in pass 2, except this time we're setting the next one, because which texture has changed after pass 1, it becomes the next one. And then here we do this, and then we don't want to do this here. Okay, so that does the double buffering. Okay, and this is not correct. Okay, so actually instead of doing it this way, what I'm gonna do I'm going to say cur render texture 0 will be this, and cur render texture 1. We'll do the swapping in one place. This will be much more clear. here we want cur render texture 1. No. See if this makes sense. Now there's something I need to do. It's this binding that I'm doing for text ID that I need to no, so that one's fine. No, it's not fine. I need to do those dynamically, not once. Text ID. Technically, I only need time in this guy and not in the other one, but okay, does this even build? Okay, it's very unlikely that this will work, but here goes nothing. Oh, that's interesting. Something's happening. Go over just a little bit. This kind of hacky code is can be kind of difficult to understand. So what am I doing? So on each iteration, we are swapping which texture we call rendered textured 0 and which one we call rendered textured 1. Let me just make sure that there's no more of these being referred to in the code below. Yeah, okay, that's good. So we only have cur render texture 0 and cur render texture 1, and we are swapping between them with the idea that one of them will be an input for first pass, and it will become the output for the next pass, right? Oh, actually, yeah, did I do that right? Oh, right. For the darkened texture, we need to, oh, right, yeah. We want to point rendered texture Okay, sorry, this is supposed to be 0 here. This is where we plug in the 0, 1 as the input texture to this second pass shader. And we write to render texture 1. And render texture 1 is supposed to be fed in here, yeah, for the draw. And then we swap the two. So maybe that's what I needed to do. Not quite. This is kind of a misnomer here. So let's see, this should be more like just frame buffer textures or something. So we bind this guy again. We say we're going to use this program, and this time for 0 we use render texture 0 as the input, which is rendered texture. So when we get into here, rendered texture, which we are sampling, should be whatever the current 0th one is. And we read that one and we mix it and bring it, darken it to 0 and make that the final color, which would be writing to current rendered texture 1, which is what we draw. Now, when we're done drawing, we come back up here and we swap. Let me make sure this logic does what I think it does. So 1 and 2 for the first round. And then 2 and 1, and 1 and 2, yeah, so. It is indeed swapping which one it considers 0 and 1, so that's fine. Wait a minute. I am missing this layout in my second darken, so it doesn't know to bind it to that one. That's kind of important actually, since I need to tell it that the output is at location 0. So let's see if that helps. Whoops. and does not help at all. What did I just do? Okay. So this is where rendered texture that comes from the darken texture program here, this rendered texture is supposed to get, we're supposed to get the idea of it here. And then we set our render texture 0 sampler to use texture unit 0. So that's where we bind it to texture unit 0, which is bound to this guy here. Yeah, technically we don't need this and this. I feel like we're getting close though. Damn it, midnight. I wonder if this should be called after we bind the frame buffer. Although I don't think it makes much of a difference, but let's just see. Did not like that. Was it really that caused it to fail? Interesting. Okay, so it was this here. I needed to set... Why? Why did I need to initialize frame buffer color attachment 0 up here? Oh, because of this? Yeah. That's why. Okay. Or whatever. And then this here could have been moved on here, I'm pretty sure. Now I'm starting to wonder whether I do need a separate frame buffer for this to work. We'll see why it wouldn't work to bind, given a frame buffer, to bind a separate texture to it. Let's see if there's anything about that in here. Right. I find it curious how it brightens. Like if I don't do this increment, then technically we should just see like a black screen, right? Oh, that's interesting. We actually see this. So what does that mean? Because that surprises me because we are rendering our lines to texture 0, ostensibly, down here when we do our here in pass 1, let's say that's going to be texture 0. We say set that frame buffer texture to this guy, and then we draw here our lines, And then after that, in the darken texture pass, oh right, because we read from 0. Oh no, okay, so this is totally normal. So we read from 0 and draw and write to texture 1, and then that gets drawn. So like if we didn't do this part here, I guess we would get either an error or we'll get black. Let's see. Yeah, so we get black. So this makes sense to me, right? So now the question is, why is it that when we write out to texture 1, okay, let's go back to trying that other thing I did earlier, which is, okay, so that's that. So if we go back into the darken, and instead of using time like we did earlier, we just put in like 0.5. So we should get like a fixed darkened view, and we do. So we know this is doing its thing. So maybe it's this time value that's not doing, it's not being passed in properly. Let's take a look at time. Which is really frame time. So we are grabbing here a texture ID for time. Here, and we're writing to it. Okay, so let's try something else. Let's see if we were to pass in that a constant like 0.5 instead of the real time. Does that work? Or let's say even darker, say 0.8. That seems to work, and if I put like 0.2, yeah, so it is taking the time into account. What it's not doing is it's not, the swap isn't doing what I thought. So after we've drawn, we first draw into here, we darken into here, we render that. Now we swap, right? Now we're supposed to draw into the darkened one, and then that guy is supposed to output into the other one. So that should work. And I'm not doing any clears except for here, right? Nope. Yeah, we're not doing the clear here. So we only clear the output, the screen, which is fine. I mean, technically we don't even. Oh. How did that even compile? Yeah, no change. But it's okay to clear the screen. Swap. Now we've swapped, and we come back here. Oh, okay. I actually had disabled the switching. So now with a fixed value, does it darken? Oh, interesting. Interesting. Holy shit, it's working. It's getting darkened to 0.2. Lots of questions like, why is the blue still here? The blue background. If we're drawing, if our pixel shader is bringing all the pixels to 0 for the full screen quad, it should all go to say 0.2 in this case. Yet that's not what we're seeing. It's only the lines we draw. Yeah, what I keep thinking about is that it doesn't make any sense that if we're drawing in the second pass, we're just taking that texture from the first pass. So we just drew these, like say 2 lines, but that's a full screen texture. Now we take that texture and we draw it in the second pass as 2 big triangles, right? That's what we see here. That's what this code is doing. It's saying, you know, draw 2 triangles. And when you do that, the pixel shader should basically shade every single pixel of the screen, right? Or like, yeah, every single pixel of that texture onto this second texture. And so if we're darkening each one of those, the whole screen should go dark, not just part of it. So like if I go back here and I remove the switching of textures again, just to get like the fixed, you know, one texture stays the same and the other one and the other one. So like this, we saw that if we play with the time value, okay, this one's unnecessary. Here. We say, let's say 0.7. Okay, so that made everything dark, right? Darker. So actually, it did make the screen darker. Oh, I think that's it. If I put 1 here, we will get black. Okay, so it does make sense. It's just that we're not getting the accumulated effect. So there's black. So yeah, it's just we're not, for some reason the accumulated effect is not happening. I wonder if the problem is that when we start drawing into the first one here, it somehow clears it, even though I'm not clearing it. Doesn't make sense. Because that's the kind of behavior we're seeing. That doesn't make sense. I'm sorry, I know I'm not showing what's happening here, which is just because this program really doesn't work well when I... Okay, here. So this actually here is interesting. It looks like the program is sort of working because basically I'm doing the swapping, and the fact that we only see the 2 lines I'm drawing and the rest is black means that it is going to black. And it's doing it like this is happening very quickly, so I'm not using time here, but I was just doing some experiments. Like if I put 0.01, then we get this kind of different behavior, which I don't quite understand. The darkening and somehow stopping. Wait a minute. Oh, you know what? It's not a linear interpolation that we want here. That's that. I keep making this mistake in my brain. Because this is not linear. This is like a... This is kind of like asymptotic, right? Like basically it's some kind of quadratic approach towards the target. What we want here instead is we want to move at a given speed towards 0. At a linear speed. Yeah, it's not a mix. We just want to subtract the time values, that's it. It's more like we want to sample the texture at X, Y, Z and then subtract like this, I think. Oops, wrong Visual Studio. Okay, I think it's actually working now. Let me see. Let's pass in time for real. Yeah, and it's not time, it's wait, why didn't that work? I think it's because I need to clamp because my values get, that's it. If your values go into negatives, then it actually makes it white. That's why I'm getting this white effect. Okay, so I need to clamp this value. How do you do that again? GLSL clamp. Or min, really? No, it's min. Okay, I'm getting black. Is it min? Oh no, it's max, right? Yeah, I always get that one wrong. The max value between that and 0, yeah. Still going to white. I'll just show you what it looks like. But if instead of this, I put in a fixed value, is my frame time not corrected? I should check if my frame time is computed properly. That would be awesome. Ah shit, that's why. Idiot. Stupid mistakes. Okay, now let's try this again. There we go. Just bring those two lines back on screen. There it is. Finally. Check that out. We are finally getting what I've been wanting. Basically this cool fade out effect. Now obviously on the Vectrex it'll go much faster than that. You know, it'll be some kind of factor that will pass in, you know, for like right now it's basically moving at a speed of going to 0 from 1 to 0 in 1 second, but we'll have some kind of multiplier. Like I can kind of fake that here by just putting some scale factor here, right? So if I say I want to go, you know, 5 times faster, so it'll take 0.2 seconds to get to 0. And then that looks a bit more like a Vectrex, you know? Probably a little bit faster too. Oh man, that's awesome. Phew. So my bug was two things, what I was chasing. One was I was computing a negative frame time. I really should have checked this. I was subtracting last time minus current time, which will always give a negative value, right? Or 0. So it's current time minus the last time, which will give us the positive. So I was passing in a negative time. And then in my shader, I was saying take the maximum of this value in a negative time. Which means that, no, sorry, that's it. I was subtracting a negative time, which means I was adding it rather than subtracting. And so then it was going to basically to white. That's why. That's exactly what was happening. It was not going to black, it was going to white. And that's why we saw that fade to white. We do need the max though, I think. If we don't put the max, actually what happens? Hey Defense, thanks for the follow. Yeah, so I'm getting white here. Oh no, link failed. What's the problem? Vec3 parse error. I think I was missing a paren. Max. Oh right, it's basically here. I'll just copy paste this. So if we take off the max, does this still work? Like, do they get automatically clamped at 0? Looks like they do. Let's just see what they say about vector subtraction. No, that's not what I want. I don't know. Does anyone know? Does anyone know if I'm supposed to clamp? Does it will vector subtraction in GLSL? I guess it makes, of course it will produce negatives. It's just vectors. So I'm gonna go with the clamping here. I mean, what I think happens is that a negative color is black. Like if all three components are negative, it'll be rendered as black. But if it eventually, like if it underflows, then it would suddenly be like a huge color. So yeah, that makes no sense. So we do need the clamp. All right, so this is great. We have a nice like basis to start from. Obviously this code would need massive cleanup, but that's fine because when I bring it into the emulator, it will be cleaned up. I can't wait to see my Vectrex emulator actually rendering that way rather than this, what I have right now, which although seems okay, is really not okay. And it really shows when let's say when we start the game here and we're going to see the big ship, how it kind of jumps down and looks really, oh no, this is Space Wars. But yeah, like if we take off this here. It's like, it's kind of jittery, you know, it's not smooth. We just see a lot of jitteriness because I'm not doing any kind of fade out. Like this kind of weird, janky jitteriness that we see. Or when I'm moving my ship, there's this like trailing ship that you see, but that's not like and I'm doing that effect on purpose. That's just because of the like hack clear that I do after you know, 50 frames per second. At 50 Hertz, I'm just clearing the screen no matter where we are in the middle of drawing, and so we end up seeing this like mid-frame in the middle of drawing one frame. It's kind of like VSync. It's the VSync problem, right? It's tearing. We're seeing part of the image from last frame and part of the image from next frame because I'm happen to be clearing somewhere in the middle of that frame. So that's, you know, we can see it on these asteroids here. There's like this kind of double image that we see. So it's very similar to the VSync problem. That's going to disappear because everything's going to just be drawn, cleared, and things are going to fade to black the way they're supposed to. And that's going to look nice. Okay guys, well, I went way over the time that I thought I would tonight, but I'm really glad because I'm glad to know that this is working and we have a great basis to start next time from. So thanks for watching everyone, and hope to see you next stream. Take care.